All right, welcome back to another episode of Science with Surbeck. Today what we're going to be talking about is hydrates. And before we get into the details of these notes, there's a couple of objectives I want you to be able to accomplish by the end of this video. So objective number 1, explain what a hydrate is and how its name reflects its composition. And objective number 2, determine the formula for a hydrate from laboratory data. So we get started here with a hydrate. And I just want to start out with a definition of what a hydrate is. A hydrate is defined as a compound that has a specific number of water molecules bonded to its atoms. And I should use the proper term here, that is bound to its atoms. So it's a compound with this added bit of water. Now, the number of water molecules associated with each formula unit of the compound is written following a dot. So to help explain what we just wrote down, let's go through an example. And this example is sodium carbonate decahydrate. So for sodium decahydrate, sodium carbonate decahydrate, we would first start out with the compound sodium carbonate, which would be Na2CO3. And then we worry about this business that we wrote just above. To show that it is a hydrate, or water molecules are bound to this particular atom or molecule here, we show that, hey, the dot represents that this sodium carbonate is surrounded by waters, and the specific number of waters is 10 for decahydrate. So that's what it would look like, to give you an example, and we'll go over how to name and write the formula for each of these hydrate molecules. Now, something to know here that hydrates, they're often heated to drive off water so they can be analyzed. Now, after the water is driven off or heated up to be driven off, the substance that remains after that water is heated off is known as anhydrous, or without water. And so you may hear something such as anhydrous ammonia. That means that is ammonia without water attached to it. That means all that water has been driven off via this heat method. Now, you may be wondering, okay, well, we have compounds. What's the whole point of these hydrates? What can they do for us? So just to list a couple of things that hydrates are useful as, we have the following. Anhydrous forms of hydrates are often used to absorb water, especially during shipment of electronic and optical equipment. Now, what can also be used with our anhydrates is that an anhydrous form can remove moisture from the air and keep other substances dry. So an example of something like this would be a desiccator, which is used in a chemistry lab that helps absorb water from the air. Now, hydrates can also be useful, and one of their uses is being used to store solar energy. One example of this is sodium sulfate decahydrate, and that compound can be used to store that solar energy. So how sodium sulfate decahydrate works is by this. The sun's energy is absorbed by the compound. And then as the temperatures cool in that compound, they release that stored energy from what the sun heated them up in. All right, so now we have some basic understanding of what a hydrate is and some of the uses that a hydrate or an anhydrous compound can do for us. Now what we're going to shift gears to is how to name or how to write the formula of a hydrate. So again, we'll shift gears a little bit here, but all right, so naming hydrates. The way that we name hydrates is as follows. The first part is that we just name the ionic or covalent compound using their conventional naming method. The second step here is to determine the number of water molecules in the compound. So the coefficient in front of the water is the number of water molecules present. Now, prefixes are used to represent the number of water molecules present. Now, I'm not going to write this down, but these prefixes that are used are the same prefixes used to name covalent compounds. Now, once the prefix is named, tacked on to that end of the prefix is the suffix hydrate. All right, so let's try these steps in a couple examples. We want to know the name of CaCl2. So CaCl2, the first thing that you should be asking yourself, is this an ionic or covalent compound? Well, it's ionic. So the first thing that we do is we look at the first element. The first element is Ca. We find Ca on the periodic table, and that first element, remember, there's no change. We just write that down on the periodic table. So the first element, if you didn't see there, was calcium. Now, remember, the second thing in our ionic substance does get a modified ending. So yes, you could look up Cl, and Cl has the name of chlorine, but because it's listed second, or it's the anion, you need to turn to that ion formula sheet in your packet, and if you find Cl, it is not chlorine, it is chloride. Remember, we chop off that ending and add IDE. So we have the formula for CaCl2, or the name to be calcium chloride. Now we worry about this business of this attached water. Well, if you remember, the number in front has to be represented by a prefix. Well, there's no number, so we assume that we have one. We assume that we have one H2O. Okay? Well, we look on our prefix chart, and again, these are the prefix for covalent compounds, and they're also the prefix used to name hydrates. We look and we find the prefix of 1 to represent mono. So we write that prefix mono down, and then the steps say, hey, after the prefix mono, or after the prefix, you need to add in the word hydrate. So CaCl2 dot H2O becomes calcium chloride monohydrate. Now let's go backwards. Let's go from the name to the formula. So we have copper 2 sulfate pentahydrate. So the first thing that we need to do is we need to identify, well, what is the formula for copper 2 sulfate? So again, copper. If we look this up on the periodic table, copper has the element symbol Cu. The 2 represents that it has a 2+ charge. Now sulfate, you can spend all day looking for sulfate on the periodic table. You will not find it because it is a polyatomic ion. So sulfate is SO4 2-. Now, when we form this formula, it becomes CaSO4. So I write that down, CuSO4. Now we draw a dot because it's a hydrate, and then we have to look up what is the prefix penta standing for. And so the numerical value of penta is 5. So we put 5s, and now remember, hydrates represent water. So we write down H2O. So our formula for copper 2 sulfate pentahydrate becomes CuSO4.5H2O. All right, so now we want to transition a little bit, and we want to follow the steps to be able to calculate the formula of a hydrate. We can calculate the formula of the hydrate. So the steps to calculate the formula of the hydrate are as follows. Step number 1, you need to determine the formula of a hydrate by finding the number of moles of water associated with 1 mole of the hydrate. So that's our objective. Find the number of moles of water associated with 1 mole of the hydrate compound. So the first step that we need to do to accomplish this is write down the number of grams of hydrate given. The second step is to determine the number of grams of water. Now this is done by subtracting the grams of anhydrous substance from the grams of the hydrate given. The next step is to determine the number or the molar mass of the ionic or covalent compound and of water. The next step is to convert the number of grams of water and anhydrous substance to moles. The fifth step is to divide the number of moles of H2O by the number of moles of anhydrous substance. Now, the ratio of moles of water to moles of anhydrous compound is the number of water molecules present in the hydrate. And then once you know that ratio, you can determine what the formula is given the lab data here. So let's go ahead, let's try these, let's put these steps to an example. So we want to calculate the formula of the hydrate given the following scenario. So we have a 2.5 gram sample of hydrated copper 2 sulfate. And ultimately, we don't know what or how many grams of or molecules of water we have here. And what we do, we put it in the lab and we heat this substance up. So we heat it up to drive off the water. And after we heat this, we only have 1.59 grams of this white anhydrous copper 2 sulfate. We want to know what is the formula of the hydrate and also name this hydrate. So if we think about step 1, we need to determine how many grams of water and how many grams of anhydrous we have. Well, the substance or the problem says we have 1.59 grams of white anhydrous. So what we need to do to find out the number of grams of water is we need to take that number and subtract it from 2.5. So again, this is just to determine the number of grams of water. So I'm going to subtract the number of grams of anhydrous substance. Okay, so we subtract this out. 2.5 minus 1.59. If you don't feel confident, you can put it in your calculator here. So we have 2.5 minus 1.59, and we get 0.91. Now that 0.91 is the number of grams of H2O, okay? And so what we're going to do now is we're going to convert 0.91 grams of H2O and 1.59 grams of anhydrous copper 2 sulfate to our particular moles. So what we're going to do, we're going to do a little bit of stoichiometry here, or conversions. 1.59 grams of copper 2 sulfate. Okay. Now, to help you out a little bit, I will give you the molar mass of copper 2 sulfate. So the molar mass of copper 2 sulfate is 159.62 grams per moles. Now, we already have grams, so we need to cancel on bottom grams of copper 2 sulfate, and we're trying to convert to moles of copper 2 sulfate. Gram to mole, this big number, 159.62 grams is for every 1 mole. So we put down 159.62 grams to every 1 mole. So in our calculators, we do 1.59 divided by 159.62. When we do this, we get a very, very small number of moles, but we get 0.00996. And I'm going to round it to there. So there's 0.00996 moles of copper to sulfate. Now we need to convert the number of grams H2O to our number of moles H2O. So we start out by doing the same thing. We have 0.91 grams of H2O, and we need to cross cancel out our grams. So we'll get grams of H2O on bottom, and we'll go to moles of H2O on top. Now, to help you out again, the molar mass of water is 18.02 grams per mole. So once again, this big number is associated with grams. So we have 18.02 grams for every 1 mole of H2O. So in our calculators, what we're going to do here is we're going to take 0.91 and we're going to divide it by 18.02. We press enter. We get a value of 0.0505. So we get a value of 0.0505 moles of H2O. Now we need to find that thing known as the ratio. And how we find the ratio, it's very important here that you take the number of moles of H2O, and that becomes your value on top. So 0.0505 moles of H2O divided by your number of moles copper 2 sulfate. So we divide this by 0.00996 moles of copper 2 sulfate. And so what we do in our calculators is we put 0.0505 divided by 0.00996. We press enter. And on this, I know we have some decimals here, but this is a ratio of very close to 5. And it's probably because how we rounded it. For this problem, again, I'm going to emphasize that, for this problem, we can round that to 5, okay? So that means there are 5 H2Os in our formula, okay? So to answer the question, hey, what is the formula? Well, the formula, it's going to be the same. It's going to be copper 2 sulfate, just as we saw here. This 5 represents or replaces that X. It shows us how many water molecules are in this hydrate. So we put a dot to represent that we have a hydrate, and then we put 5H2O, and so our formula for copper 2 sulfate becomes something like this. Now, how we name this down below here is as follows. We name copper 2 sulfate just like it's named up here. So for the name, we have copper 2 sulfate. Then we put the prefix for 5. So we look up the prefix for 5. The prefix for 5 is penta, okay? So the prefix for 5 is penta. So we put penta, and then we put the name that we call water in this scenario here, which is hydrate. So CuSO4.5H2O is known as copper 2 sulfate pentahydrate. Okay, and so that becomes our answer. Now, there's one more thing that I want to go over, and that is how to calculate the formula of hydrate in the lab. Again, this was given lab data. Now we want to go one step further. Well, how do we calculate the formula of a hydrate specifically in the lab? So we'll change gears here. We'll go back to our steps for our hydrate. And the first step to do this is you need to weigh the hydrate. The second step is to heat the hydrate to drive off the water. Once you have driven off the water, you need to weigh the anhydrous compound. Once you have weighed the anhydrous compound, you need to subtract the difference between the anhydrous and the hydrated compound to determine the number of grams of water and the number of grams of anhydrous substance. That here in the formula is number of grams H2O is equal to the number of grams of hydrate minus the grams of anhydrous. The fifth step here is to determine the molar mass of the ionic or covalent compound of the water and the compound. Once you have determined the molar masses, what you need to do is you need to convert the grams of water and anhydrous substances to moles. You then, in step 7, need to divide the number of moles of water by the number of moles of anhydrous substance. And then in step 8, the ratio of moles water to moles anhydrous equals the number of H2O molecules present in that hydrate compound. All right, so this concludes another episode of Science with Surback. Hope you've learned a lot about hydrates. And as always, if you have not already, please subscribe.